just to open up to show that FEO, we're trying to make strides to develop mariculture in the Caribbean and just give you a taste as to what the potential is in the Caribbean. This week, we have the privilege of having a presentation from Valerio Vitellini. He's the cage consultant who was hired for the sub-regional mariculture project we have in the Caribbean. And he comes with so much experience from, the Mediterranean as far as cage mariculture production, as far as cage engineering, seed production. He really has a good handle about, the whole value chain when it comes to mariculture production. Today, the webinar series, or the webinar two, is titled Building and Managing Cage Farms, Engineering and Daily Operations. So he's going to be presenting on how you can build cages, the metrics, the models of cages that are currently out there when it comes to cage mariculture, as well as speaking to the requirements of daily operations when it comes to a cage mariculture farm. All the presentations are important, but I think this one is really important in the sense that now it contextualizes what it would take for people within the Caribbean and elsewhere to be able to participate in finfish mariculture farming. I'm very excited about his presentation today. He was a really, really, big support mechanism, big help when it came to building the cages and teaching people in Jamaica. And I think a lot of the information he will provide is information you will not find in a book. This is from somebody who really has hands-on experience in the field and has learned by doing. So I think that this will be very fruitful. We're going to be recording the meeting as well. So for those of you or for your colleagues who are not able to join the meeting, we can share the recording afterwards. We had some issues with IT for the first meeting, but hopefully we will solve, and I will start to send both the first and the second meeting recordings soon. So with that, Corey, are you there? Did you give Valerio presentation privileges?
Yes, you,
You did? Okay,
yes, I did.
so yeah, I introduced Valerio. He's going to give his presentation. If anyone has any questions, feel free to get into the chat or raise your hand similarly to last time. I don't know, Corey, did you give because what happened with Stuart last time is he gave everybody the option to be able to speak and raise their hand. Could you do the similar thing today?
Okay, no problem.
Yeah, do that. So everyone has the option to speak and raise their hand. And that way this can be more of a discussion. And like I said, group chat or raising hand works. And then hopefully we can make this a learning experience for everybody. Okay. Thank you guys. And now we start with Valerio Vitellini. Hello.
Mohammed, can you hear me?
I
Hello,
can hear you
Mohammed.
now. I can hear you.
Yeah, can you hear me?
Yep, I can hear you.
Okay, can you see the screen?
I can see your screen too.
Okay,
You want to
so
put it in a presentation mode?
yes, I will.
Yeah.
So
Okay.
this is Valerio Darini from Italy. I been working in aquaculture since 18 years old, 18 years, from let's say from larva rearing to on growing in sea cage. That's my mainly job since the last 10 years. So I will start with a brief presentation of the cage technology, focus on my sea, the Mediterranean, and then we will focus on the floating cage management from installation to managing the production. So let's go fast because we don't have a lot of time. Let's see that first cage in Mediterranean start end of 70 in Yugoslavia. But let's see that the first farm that moved offshore was beginning of 19 in Italy. The beginning, the structure was mainly done by steel, by iron, and they suffer a lot, of course, the sea because very rigid structure. So this was in Spain when we were with the square models. So let's see that polyethylene high density polyethylene start to take place to instead an iron because it's much more flexible.
Hello, Valerio. Sorry to cut you on. Where are you meaning to change your slide or no?
Yes, I'm changing the slide.
Okay, from our side, it's not showing up as you're changing the slide.
What do you mean? You are stick on the first slide?
Yeah, we're still frozen on the first slide.
I don't know. In my screen, I see the slide.
Mm. Don't know, maybe try to exit out of presentation mode to see if it
Okay.
makes a difference.
Now you see moving the slide now?
Now I can see. Now I can see. Yeah, now we can see.
So let's do in this way without presentation mode.
Yeah, maybe just like this then. So
Okay,
the slide you're on is the first trials with marine cage farming, right?
yes, this was in Yugoslavia end of 70.
Okay, so we can start, yeah.
Now you can see some picture. This is iron
Yeah.
structure, okay? You see the seat. Of course, we don't have animation here, but maybe I can try again to put on presentation mode the moment.
Maybe just leave it like this, just in case.
Okay, okay, leave it like this. So I was saying that different material like polyethylene was taking place in the 80s because it's much more flexible material, strong material with can be waterproof, so we can have a big buoyancy. Of course, we need to move the cage, so we start to have some configuration of mooring system with the anchor line, okay, with a certain grid. We will see a bit in the detail later. And then, of course, we need to moor the cage. Sorry, we need to moor the net so that, of course, because it's the net that represents the large surface again the storm, again the sea. So, as you can see in the picture, we have the connection like a minus 10 meter here. Then, of course, with the increasing of the diameter, the material, so the biggest of the dimension of the pipe, we can go even with we started to go offshore with floating cage, like in this picture. I mean, in open sea where we face big waves. Of course, the cage, the floating cage, we will see later, are much more better to work, easier to work to respect a submersible cage because so the operativity is much better. But of course, I will show you in this presentation even other kind of cage very fast, like submersible or submerged cage that are needed when we have a very exposed site or maybe when we have like hurricane site. So let's have a brief overview of some other kind of cage. This, for example, is a submerged cage. Okay, is a Dunlop. This is a ocean spar. We have a farm with ocean spar in Panama, as you know. This is ocean spar again. Was a system that was abandoned because of just some problem, big problem with some storm. You can see a picture now. This is aquapod, is like a spherical cage, small volume to respect the floating cage, as we will see. This is a picture how is working with the fixed system connected to the boat. This is a tension legs cage from Refamed. You see, this cage is not contrasting the waves, but is a seconding, let's say, the wave is follow the waves. That's different way to work with floating cage, but of course, in very exposed side, we can know. I mean, floating cage can be a problem. These are some example of submergible cage, so cage that can stay on the surface but can be even submerged, like this. For example, putting air or removing air, we we will have the cage sinking or floating. This is a TLC submergible cage. And this is like a floating cage that can be submerged because the mooring system is particular. But again, I want to focus on floating cage, so I was very fast on this presentation just to show some technology. But let's start to speak about floating cage because aquaculture uh, took place, as I told you, from the 80 and the huge development of aquaculture was in floating cage. Of course, let's see that we have much less investment cost to respect some submergible cage, so lower cost. But we cannot do floating cage inside that are too exposed. Uh, as I will, you can see, I suggest like inside where the significant wave A is higher than 6, 8 meters, floating cage can be a problem. But we have floating cage in a very open sea, rough sea. So the volume is very big because if I make like a 30 diameter cage with 12-meter net deep, I have more than 7,000 cubic meter. So compared to other technology, bigger volume, and then easy management of the production cycle from stocking to check, to sampling, to clean the net, to changing the net until harvesting. So this means lower production cost, so higher margin. And we will show how very quickly how to assemble a cage. I mean, I will show you a lot of picture. I make like a tranche of presentation, but then I will jump to some pictures. So let's say that floating cage are made by pipes, a high density polyethylene pipe. So the cage are welded starting from pipe, like for a water line pipe. So for sure it's not difficult, but let's see that. Ecco, this is a example of some machine, a welding machine for weld the pipe one together. Once we done the line, as we will see in the picture later. What is a cage is shown in this slide. I mean, this is a couple of slides. We have two or more than two floating tubes with a diameter. I mean, I speak about the diameter of the pipe that generally is a range between 250, like we did in Jamaica, until 400 millimeter diameter pipe. Always we are speaking about high thickness pipes, so more than we call PN16, but maybe more than 3 centimeters for 315 pipe. Okay, these two rings are of course waterproof. Okay, and is the part where we connect the net on the water level. on the floating cage. On the oh, see, yes, on the floating. Let's see that these pipe are filled completely with ESP cylinder, so foam cylinder, to prevent sinking in case of a lot of fouling and some breakage, even if it's very robust material, very resistant, but in case of a big ship. Then we have a smaller pipe that we call handrail pipe, that generally this pipe has a diameter in between 110 140 millimeter. Okay, even in this case it's PN16, so thickness pipe. This is around 1 meter, 1.2 meter above the sea level. Okay, and on this pipe we connect the emergence part of the net. Okay, so how we keep together this pipe, so the floating ring and the handrail with the brackets. The brackets are always in this case polyethylene elements, okay, that held together the pipe. Generally, the brackets has a L shape, but can be even triangular. But we will see a lot of pictures, guys. So just and let's see that we have one bracket each 2.5 meter on the circumference. We can have quite different type of bracket formats, roto printed in rotomolding or injection molded. We will see some example later, but let's go. Then we have like a ballast system where we connect the net. The ballast system is connected to the floating pipe, to the floating tubes, and we connect the emergence part of the net to this system in order to keep open the net, in order to keep the volume. Generally, another element that is composing a normal floating cage is a HDPE element, always same material, generally circular in shape, that is moored in the middle of the cage. And this is for lifting the anti-bird net, to keep the anti-bird net far from the water level, because bird can make a lot of damage. So I will show you, okay, this is a classical cage. You see the pipe, the floating ring, okay, that's a bigger pipe. You see the small pipe out of the water. I mean, that is the handrail. Then you see the bracket in orange. This is the hammer part, the part of the cage out of the water. You can see the support in the middle, that is for lifting the anti-burn net. Then in the below, you can see like the ballast system. In this case is a sinker tube. The sinker tube is just like a pipe with the same circumference, smaller diameter pipe, but with a chain inside, with also the water is going down inside the pipe, so it's a lot of weight. Is connected with rope to the floating pipe, and then the net is connected to the sinker tube. We can have even a single ballast. Okay, let's see that for each bracket we tie the rope on the pipes, on the floating pipes, with a ballast that go maybe minus 10 meter, minus 12 meter, and we can use this rope for more the net. Okay, in this example on the left, you can see single. Let's see in the middle picture, you can see single ballast moored connected to the net cage. Or on the right, you can see a sinker tube where the ballast is just one ring. Okay, let's speak a bit about mooring system, and then we will open a session of picture and even some video. Let's say that the typical mooring system for a floating cage is a grid, okay? Inside the grid, each cage is moved inside a square of rope. Okay, this square of rope is running under the water. Okay, this because each corner of the square there are buoys, even big buoys. Okay, that keep the grid at the level that we want. Normally, it's around -6 meters. Okay, so the buoys are connected by chain or rope to the connection element that general are iron elements that we call plates or ring, iron ring, but can be even other material. Let's call plate this element. So all the rope are connected to the plate because we have like that the rope that make the side of the square, okay, the side of the box are connected to this plate. The rope that move in the cage is in the middle of the square, is connected to this plate. And then even the mooring line with the anchor are connected to this plate. So these are very important elements. Then, as I told you, we have anchor, so we have mooring line. Mooring line can be even 7 times more deeper than the deep of the side, so very long. Okay, and then generally we have even a heavy chain, heavy ground chain, maybe even 40 meter of 17 kilo per meter chain, so big chain. And then we have anchor that can be even more than 2000 kilo, but it depends from the site, depends from the position. So this is some picture even about mooring system, but the function of the mooring system is to distribute in equal way the loads to which the cage are subjected during a storm. So the force of the sea are, let's say, discharged onto a larger number of anchors without directly impacting on the pipe of the cage. Okay, for example, the chain that is connected the anchor to the mooring line that go to the plate is very heavy, so a lot of energy of the waves is absorbed in lifting from the ground the chain. So it's a system that is distributing the force. This is a real scale mooring system from top. Okay, in the middle you can see the cage and each corner of the. Let's say that each plate is leaving one or more anchor, as you can see. Anyway, it's not difficult. And then let's see some picture that make we clarify even some aspect for sure. So let's start from cage construction. Okay, let's start from what we did in Jamaica. Mohammed, can you confirm that you can see the picture?
Yes, I see the picture. You're talking about the diagram of the cages?
No, 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 no. This cage is a Jamaican cage. The cage we do in Jamaica. You can see the picture, no? Huh?
No, I don't see it.
I cannot put in presentation. Let's try to do like this.
Mm.
You see now the picture?
No, I don't see the picture.
Mm. Do you see the folder?
No, now it just shows the PowerPoint presentation.
Okay. Mohammed,
Now I can see. Yeah, now I can see.
and you can see now?
No, so what I can see is I can see the folder. I can see the folders and I can see the photos within the folder.
Mm. If I open the photo, you cannot see, huh?
Mm-mm.
This is a problem, Mohammed. Let's try to close the PowerPoint presentation.
Worst case, if it's maybe you could send me the photos and I can just show it at the end of your
Yeah, I
presentation.
don't follow, Mohammed. No easy to find you.
Mm.
Okay, I shut down the, let me try again, okay? You can see, Mohammed,
Yep, I can see now.
Yeah.
even if I move from one picture to other picture, you see?
Yep, we still see.
Okay, so this is some picture from for cage assembling, okay? Starting from the beginning. This is what we did in Jamaica a few times ago. So this is how to make the line. First things we make the line. We put, of course, the foam inside. Okay, you can see the line. This was a small cage. Let's see that is 12 diameter cage. How we will see, generally we used to raise fish in bigger cage. Anyway, it's just the same. So this, for example, was the machine we used in Jamaica for weld the pipe, assembling the line. These are the guys that are marking, sorry, I go, that are marking the brackets on the pipe. These are the upper part of the brackets that we are putting on the handrail. These are the guys that are inserting the brackets in the pipe. Here you have the cage with the brackets still online, but with the brackets inserted. And now we start to close the cage, okay, to make the ring. So this case it was not easy because as smaller is the cage and as how bigger is the thickness of the pipe, is harder to close the cage. Anyway, we did the job. You can see we use some rope. This was the second ring closing. So we close the second ring. This is the result. Then we close even the handrail, as you can see in this picture. Big machine, and generally is even better to use a smaller weld machine to respect what we used in Jamaica. Here is the cage done on land, and here was the installation of the net. That is something that generally we can do when the cage is moored. In this case, we were doing this on land. I just have some picture. The guys were training. These are two cage, 12 diameter cage that we moor in Jamaica. This is the cage moored. This is just a bracket, okay? Just to show you a kind of brackets because we have many kind, different kind. This, for example, is other kind of brackets. This is bigger cage, is like 28-meter diameter cage. This is 30-meter diameter cage, so bigger pipe. This was a 350
Okay, let's see.
diameter pipe. In this case, we have other two pipe in the floating ring. Okay, smaller pipe. This is more easy to work on the cage. Okay, but let's see even some cage in the water. You see the cage, the picture, Mohammed?
Yeah, we can see.
I don't put on presentation because otherwise we lost. This now I will show you some farm, some cage, floating cage farm. This is in Italy, and you can see some example of cage in the water. This pipe is for a feeding system. We will speak a bit later about the production cycle in a floating cage, but let's start looking some farm. So this is another kind of brackets. As you can see, it's triangular. Okay. This I think was in Tunisia. I think maybe 25-meter diameter cage, probably. The guy were feeding now, feeding operation. These are sea bream. This cage is full of sea bream. You see, always we have this structure in the middle for lifting the net, the anti-bird net, because we don't want that the bird can arrive, at least can arrive easy to the water. This is a big farm. This is in Italy, in Gaeta. Different kind of cage. This I think is in Croatia, just to have some different floating cage farm example. You see, the structure to lift the anti-bird net can be even very high, but if you have a site with big waves, it's better to do this structure more large, more wide than high. So maybe we have in cage of 30 diameter. In 30 diameter cage, we have anti-bird polyethylene structure that is 12, 14 diameter. So very big, because it's very important to keep the the anti-bird net high, from far from the water. This is always Gaeta farm where I was working. You can see the grid, but I will show some picture about the grid system now. Almost done. A lot of fish eating. This is in Croatia, another farm in Croatia. They were doing vaccination here. Very flat sea. And these are 30 diameter cage in Follonica Golf in Italy. You can see the cage in the mooring system. This is a farm with more than 60 cage. Here we have smaller cage. Okay, let's see some picture on mooring system. I am right. Each time I have to close again and share again. You can see now new picture. This is a just a draft of a grid system. Okay, this is a draft of the plate, the elements, the connection elements that is under the water. Generally is under -6 meter. We will see even my video now. This is a double plate. So, for example, backing on this, the red rope are the side of the box. Okay, the green rope with the chain are go to moor the cage in the middle of the square. Outside we have anchor. This is a video. You can see the video, Mohammed.
Yes, we see the video.
Okay, thanks. This is a plate. This is a typical plate. This, for example, is the anchor with a submergible buoy. This is the grid. You can see two rope with the chain that are the rope that go to the cage in the middle of the box. Different tension. These two rope go to the cage, you see? So this is a typical plate, and this is from side. You can see the buoy that is standing the plate at the deep that we want. And from the plate, we have the rope that go to the cage, with the rope that go to the anchor, to the chain and the anchor, and of course the rope of the grid. So this is a new plate. This is what's happened in a few time. I mean, in some months, because iron and seawater is not the best. But this is another example of connection elements. Is a ring. It's not a plate, but it's a ring. These are shackles that are normal the elements that we use to for connection. This is an example of iron anchor. This should be around 1,000 kilo each. So big stuff. Now I show you this is some maintenance work. They are making inspection, lifting the plate on the boat. This is what we did in Jamaica for mooring system. This is a bit different system. We didn't use anchor. In this case, we use block and a buoy. These buoy are underwater buoy that stay maybe a -4 meter. So the buoy is standing the chain that is connected to the block. And from the buoy, we tie the rope that go to the cage. So in case of what we did in Jamaica, we have like 5 block for each cage. So we have 10 rope from each buoy, from each block, we have 2 rope. So 2 per 5, 10 rope that go to the cage. We were doing the job here. This is this is the rope that go to the cage. This is the knot that the guys do on the underwater buoy, -4 meter in this case. And this was the cage. We were towing the cage to the site from land. This was the installation of blocks. So you can see this was a deep of 10 meters. So to have the buoy like a -4 meter, we have this chain. And these are back at some classical floating cage mooring system. So these are jumper buoy, so no underwater buoy like in case of Jamaica. These stay on the surface. So even 2,000-liter buoy, big stuff. This is an example of plate, the connection element. These are other kind of anchors. Okay, I mean same kind of before, but maybe bigger. This is a typical rope that make the box, the square of the box. Sorry, the side of the box. This is the chain, it's a ground heavy chain that we use to connect to the anchor. And this is very important for absorb the energy of the waves. So you see, maybe we have 40 meters of this in between the anchor and the rope. So these are some pictures of one installation that we were doing in Italy of a mooring system. We prepared the boat. You see, this is a connection in between rope and the chain. This was during the operation, like a sacrificial rope. That cutting this rope, the chain go in the sea. The anchor is already in the water, connected to the crane. So, of course, we need a workboat to do this kind of installation, and we need a crane to do this kind of installation. This again is a plate that we were putting in the in the water with like a provisory rope. That is the one, the blue rope go up that was connected to a provisory buoy. We were waiting for the buoy. So picture, you see, this was agreed like 5 per 2, so 10 box for 10 cage that was just installed. This is another kind of plate, as I showed you before, a grid, a ring like this. We can avoid to put some charcoal because we can like make some knot directly. Again, some anchor, plate. This is plate in action, the boat, new grid. Okay, let's back to the presentation, guys, because I want to show you like the production cycle that we.
Valerio, would you
Yes,
mind
Mohammed.
maybe just a little bit, just maybe we can leave in case anybody has any questions so far.
Okay,
If you want, you guys can.
or we can leave all together, all at the end, or we can do as you want. For me, it's the same. If
Yeah,
you,
just in case maybe they don't have any questions right now, but just to give space, just in case they have something to say.
okay,
Anyone has any questions, raise your hand. If not, we'll just continue this great presentation. Okay, we can just continue.
okay, even because we will leave. No, sorry, this is the one to say. We will leave space for the question.
Valeria, I see
No.
I see one from Ramon Alberto Neninger. He's asking what depth and velocity water are fine or are correct.
What that deep?
What depth and current velocity water are fine.
Okay, I mean, floating cage, of course, it depends from the dimensioning of the cage and the size of the cage. Let's
Mm,
see that we should have at least one time the deep of the net we should have in between the end of the net and the bottom. Okay, so if we want to install a net of 10 meters deep, we should have no less than let's see 20-25 meters. We can do in shallow water, but of course we have to install shallow net. So, for example, 7 meter net. Let's see that for me, perfect deep for floating cage is to have a deep of 30 meter, 35 meter. This
okay.
and then about current, let's say that we can face even 2 knots of current. This is depend. I mean, we can make a dimensioning of the ballast system to contrast the current in case we have a site with high current. For example, with a sinker tube, I can put instead than 1,000 kilo, I can put 2,000 kilo, so maybe bigger pipe, bigger floating pipe. In this way, I can face even two knots of current. Uh, of course, as I said before, the problem, biggest problem is if we can have wave higher than 6, 8 meters, significant waves, or hurricane, or hurricane. In this case, if we
Mhm.
have the net installed, it's going to be a problem. We can
Okay.
go we can go forward.
Yeah, I see another question from Jerisa. But this one, it may be you're already going to answer this in following slides. But she asked, could you please share how you mitigate escape with respects to your structure, hurricane contingency plans, as well as maintenance long term? So this is a longer answer, but maybe you could just briefly give some perspective of how you mitigate escape and hurricane contingency plans.
Escape in aquaculture are a problem. It's a problem in floating. I mean, in sea cage, we have escape even on land. So this is it's not easy to answer to this question. Let's
Yeah.
see that, for example, what I will do in a place where we face hurricane is to adapt the production strategy, probably shortening the cycle, so maybe
Mm,
doing 7, 8 months of cycle, so having empty cage during the hurricane storm, for example.
mhm,
Because of course, I mean, if you have the cage with the net installed and you face an hurricane, so you have a big risk of damage of the net. We cannot be in this case. You should work with the submergible cage. So when the hurricane pass, the cage are submerged, are maybe 10 meters deep, the upper part of the cage. So you don't face problem, you don't face escape. But in case of floating cage, my suggestion should is to have the cage empty, without
mm.
net, without fish.
Yeah, makes sense. Makes sense. And then the last one I see here, but this I think is more general, is asking about insurance, that if there are frameworks of insurance for cage mariculture. From my point of view, there is. I know that within the Caribbean, they're starting to develop frameworks of parametric, I think, insurance, where you have insurance that's triggered by natural disaster events, for example. But in the Caribbean, it seems somebody can correct me if I'm wrong, but we're kind of behind as far as aquaculture insurance, which makes sense because aquaculture hasn't really developed yet to commercial, at least mariculture hasn't developed yet to commercial standards for a lot of countries. But there are frameworks of insurance that can be used. And I see here that Daniel as well as Jorge also answered. So, okay, nice. Nice. Okay, Valerio, you can continue.
Yes, we can have, of course, insurance. In Norway, there is just to finish, Mohammed.
Yeah, yeah.
There is like a system that is certificating the what do you have in the sea, and this job is for insurance issues. So the insurance has all the parameters to take in case to take the case and to insurance in case of damage of storm. So let's keep. I will not make a presentation mode. Let's work like this. And sorry for that. I will show you very brief how is the production cycle in the floating cage. For sure, again, floating cage is a big advantage for, of course, to respect the land. We don't need to care about pump, about electricity, about oxygen if we have a clean net. So a lot of save in cost, of course. Um we have very big volume to compare land or to compare even other technology. And another big advantage is the easiest to do the day-by-day operation, because of course to manage the feeding is easy, to harvest is easy, to change the net. I mean, it's something that you need to know how to do, but is a operation that the farm doing every day. So I will show you these things with this operation. Let's start. So again, a lower investment cost compared to other cage technologies inside that are not too exposed again. Large rearing volume compared to other technology, compared to land aquaculture, and easy management of the production cycle from stocking to feeding to harvest to checking to sampling and so on. So this means lower production cost. Again, not suitable for very high exposed coastal area, let's say waves, significant wave height greater than 6-8 meter, or area where we face hurricane. No, but this is so, sorry guys, I have to, we stop here, okay, then we go to see some picture about, but we already done this part of the presentation. So let's start from there. So we see some picture of cage, mooring system, mooring elements, and so on. So production cycle. Let's see that we can distinguish two phase, a pre-growing or on-growing. So let's see that the pre-growing we can consider in between 3 gram. We can put a fish in the cage very early. We can put 2 grams bream, for example, in the cage with a very small mesh. So let's say that from 2-3 gram around 30 gram is a pre-growing. Okay, in this case, generally we have very small cage, like 8-16 meter diameter, with of course a small mesh. We can even exceed the 30 gram. I mean, the pre-growing phase can even consider until 80 gram, 90 gram. In this case, I suggest a low exposure environmental because too much current, too much wave is not good for small fish. It's not good for small mesh. It's not good for small feed. So let's see that protect area are perfect for pre-growing issues. The density can vary a lot according with the sites. Of course, fish grow according to the density, so we should not exceed, especially in the pre-grow, 8 kilo for cubic meter. But of course, if we weight 80 gram to move the cage in the fish in the big cage, we can have even 15 kilo for cubic meter. So the second phase is the on-growing cage that is done in biggest cage. Let's see, normal cage in Mediterranean now are 30 meter, 32-meter cage. We can have up of 50-meter cage. We have even 90-meter cage in case of salmon. We don't need to do this big cage. Anyway, let's see that from 80 gram to harvest sites, the fish stay in a big cage. Okay, in this case, of course, we have bigger mesh. I speak about net. Final density can vary a lot, even according with different species of fish. Let's see that we can work in between 8 and 25, even 30 kilo per cubic meter. So a lot of biomass in a big cage. The survival rate can vary a lot according with the species, according with the stocking sites. But let's speak about 3 gram to harvest sites. We can have from 50 to 90 survival percent. Okay. The time that we need to raise the harvest sites is vary a lot. Even in this case, depends from species, depends from temperature. For sure, inside the same species the time that we need to raise the harvest size from the stocking sites can vary a lot for quality of fingerlings, for example, for quality of feed, for water quality, because the oxygen is very important for the growth. Of course, from temperature. But let's say that we can distinguish these two phases. For sure, in the pre-growing, we will feed the feed frequency will be higher. We will arrive to feed even 5-6 times per day. In on-growing, when we have bigger fish, we used to feed less. So let's see, 1-3 times per day. Let's start to speak about feeding because, no, Before, let's speak about stocking. Sorry. Stocking is the seed. When we stock a cage, is the input, the day zero of the cage. Let's see the general juvenile are transported from land facilities to sea farm with special truck or special boat. Okay. Maximum transport density depends from the species, but even from the temperature, a lot from the temperature. Let's see that cannot exceed 40 kilo for cubic meter, but with some species we go much lower than that. Okay, and we will need liquid oxygen. Fingerling transport and the stocking is a delicate phase during the cycle. Of course, the animal are stressed by the transport, so we can even can face a high level of mortality, especially when we transport the fish with no water flow. So the flow is the same from the starting to the end. Supplying oxygen is needed. Let's see that the oxygen should be no lower than 5, 6 ppm. Optimal is going to 9, 10. Air, stone, and darkness are needed because the water has to be in movement to avoid chasing behavior. And the air is needed even to release some bad substance from the water, and darkness because the fish are starving. We need to starve the fish for 1, 2 days before the transport, even from temperature, from duration of transport. So we need to have a dark water because otherwise we will face a lot of problem with cannibalism, with chasing behavior. So you can see an example of truck on the left, an example of well boat on the right, and in the middle is something that we use for evaluate the cannibalism during a transport. So let's start to speak about feeding. Feeding is the main activity, okay? Feed accounts for, let's say, 75% of the production cost. So feed conversion rate for sure is the most important parameter in our farm. Feeding can be manual or can be automatic. Okay, bigger is the farm, bigger is the cage, more automatic system will be used, of course. Anyway, there are a lot of type of automatic system from cannon, small cannon, feeding boats, feeding barge. We will see. You can see in this slide some picture of manual feeding. So from the bag directly throwing the feed in the cage. These are some example of automatic feeding system. So you can see a feeding boat in the middle. You can see on the left a feeding cannon that we can put on the small boat with a pump. Then we open a bag, we put it inside the cannon. The cannon has a pump that can be from water or from air. And so we pump, we throw the feed in the cage. Then on the right, you can see a barge that is a common system in, especially in salmon industry, but even in sea bream and sea bass industry. So we have a barge with a silos and a system that each cage has a pipe. Okay, and on the barge we have a dozer that is sending the exact amount of feed for each cage from each silo, so different type of feed in each cage. This is a automatic feeding system with pipe. This is some table that I send you, just that I put on this presentation, just for example, to have an idea about the frequency of the feeding during the day. That, as I said before, is decreasing with the size of the fish. So big fish we generally feed once per day. Then you can see some example of granulometry, so pellets. Pellet size, again, fish size. Okay, always we used to be a lot of conservative, so it's not a matter of mount. We have generally smaller pellets because the competition is maybe the biggest issues inside the cage, competition for feed. So as as smaller is the pellets, bigger is the number of pellets in 1 kilo. So we need to give a lot of pellets for each fish. So these are normal some advice. We can have some example of feeding speed. Okay, this with the increasing of the pellet size, we increase the speed. We cannot feed too slow because only the big fish will eat. But this is a no, it's a technical presentation. This is more a technical presentation. So let's go forward. This is another concept of optimal feeding. This is not real only in cage. This is real even in tanks. Let's see that in cage, in different to respect tank, we can work with saturation of oxygen. Okay, so we can push much more with the feeding to respect tank environmental. We can push much more with the density, with the biomass. You know, in pounds, you are facing with the water exchange. Maybe you are able to exchange the water 20% of the water of the pound in 1 day. You know, when we have like a mesh 25 with big fish inside, 300, for example, 300 gram, we have a fish in the cage with a clean net, 25 millimeter mesh. We cannot calculate the time that we can change the water because if we have some current, we can change maybe thousand, a thousand, a thousand in 1 day, the volume of the cage. So we can push with the feeding, the fish can grow faster. And this is the concept of the best feeding, the optimal feeding, because this is the blue line is SGS, specific growth rate, the red line is FCR. So we need to find the window where we are pushing the growth almost to the maximum, but without losing pellet for undigested pellet or for pellet that go across the net. So we are reducing the FCR. But again, this is not a so technical presentation, it's more a technical presentation. So another important activity that we do daily in a floating cage farm is inspection, okay? Much more easier than submerged cage, because you can go from up, okay, easy with a boat, then you jump inside the cage. Let's see that each cage is checked by divers. Average, we can speak about twice per week, but there are some farms that are checking every day. The check includes the check is made by divers and includes the collecting of mortality, the counting of the mortality, because we need to take note about the number. The inspection of the net, especially about holes, of course, the closing of the holes in case we found it. Then the checking of the ropes that are connecting the cage to the net. Okay, let's see that on monthly base, generally we used to make checking of the plates, checking the charcoal of the plates, the elements. Let's see that on annual base, we used to check the tension of the anchor line. We used to make some clean of the structure because in the water we have a lot of fouling, the growing of animals and vegetables. So we need to clean the rope, we need to clean the buoy and so on. Let's speak about floating cage, net change, sorry. Net change is a very important operation, okay? So changing the net is one of the main activity in a sea farm because maintaining good water exchange within the cage is essential for the health of our fish, for the growth of our fish, for the disease. So it's very important. So nets are changed according with size, because when the fish is growing and we can put the fish in bigger mesh, we used to change a mesh. Okay, but of course the net are changed even for cleanliness. If the net start to be very dirty, okay, the water exchange is reducing inside our volume. So we need to put a new net. Okay, let's see that in one cycle we can have from stocking to 500 gram. Maybe we can have 3, 4 different mesh size. So we start with 10 millimeter, then we pass to 12 millimeter. In the beginning, we have a bit more, but maybe 15 millimeter, and then we go to 25 millimeter. Okay, maybe we can jump 12 millimeters, so 10, 15, 25. So 3 kind of mesh. This can be an average. So you can see some picture of net change operation. We will see some picture later, so and you will better understand even. So let's see that once the dirty net is on land, we used to clean the net using a special laundry machine or even manually with a pressure washer machine. Okay, then we clean the net, we dry the net, and we store the net. So ready to be installed again. During the net change, fish may become trapped in some pocket of the net. So this operation must be carried out with caution, with care, yes, with caution, because we can even kill some fish. It's not difficult, but we need to be care and to do the operation in the right way. Alternative to change the net, there are some automatic system to that, of course, in the salmon industry, almost done by automatic net cleaning machine. So, for example, they can work with pressure disc, I mean disc that pump air or water in the net. We will see some even picture. So we can have, for example, big robots that are moved from remote from the boat from one operator. But we can have even divers that go with the pressure washer underwater connected to the boat to clean the net manually. Anyway, this is an important operation because again to keep the net clean is essential for the health of our fish. So let's focus very short on the cage, on the net, sorry, rearing nets. Let's see that during the rearing cycle, the difference between making or losing money is made by the rearing net, because we have maybe even a long cycle, some months the fish are in the water, and they are separated from wild environmental through a net. So the net is very important in fish farming, especially in floating cage, but even with submergible cage. Anyway, generally, I mean, the net for floating cage is cylindrical shape, with the top, of course, is open. And then we have the net cloth, okay, with the specific mesh size. And then we have a frame of rope. Okay, as you can see in the picture on the right, these are the rope. You can see on this picture like 1, 2, 3, 4 horizontal rope. That is normal. We have horizontal rope, okay, that run for all the circumference of the net. And then we have vertical rope. Okay, some vertical rope generally extend on the bottom of the net. In the radial rope, as you can see in the draft on this slide. Okay, so I don't want to enter in the detail, but again, net is very important. Let's see that, let's back here. You see, when we have a crossing point in between horizontal rope and vertical rope, the rope form a loops. Okay, the loops is the element, the connection point between the nets and the cage is putting a rope in between a loop and the cage. Okay, so the connection point are the loop. The number of vertical rope in a floating cage net is the same of the brackets. Okay, so you have a correspondence in between number of brackets of the cage and number of vertical rope in the net. The net can be made by various material. The most important now for sure is Dyneema because it's very resistant, but it's even very light material. But we can have nylon, we can have even polyethylene, we can have polyester. So different material for make nets. We have another operation that we used to do periodically in a farm. This is true even on land. That is the weight sampling. Okay, sample weight. So sample weight are taken periodically to monitor growth, so adjust the biomass and optimize feeding, so optimize FCR. So let's see that we can do each 3 months, each 2 months, each 1 month, it's 4 months. Some farmers are not doing this. Maybe they use just a model for predict the growth and to adjust the biomass for adjust the feeding. They use the model without make sample. Adjusting the number, they get the biomass, the update biomass. Let's see that to obtain a magnificent data, a realistic data, we need to know, we need to do like a real harvest. I mean, we need to crowd a lot of fish to trap with the net a lot of fish, and then we need to take random a sample where the fish are very crowded. Then I will suggest to don't go less than 400 fish in terms of number of sample. So don't wait less than 400 fish. Then we waited, we get the average weight. So we can adjust the feeding, we can adjust the biomass. Of course, there are automatic system to do sample weight, for example, using stereo camera, but not only stereo camera. Harvest. Harvest in a floating cage is easy operation, okay? Is carry out using a pulse seine net, okay? So same principle of a pulse seine net on the sea with a boat with crane. And in this case, we use divers to go forward with the net, to bring the net in the water, to go forward with the net. Instead of the small boat in the pulse seine fishery, we use 2 or 3 divers. Then let's see that once the fish are crowded, trapped in the net, in a pocket of the net, so in a few space, they are lifted out with a big, large scoop net that is connected to the crane because we can even lift 400, 300, 400 kilo fish. We don't want to crowd too much, but generally 300 kilo is a normal quantity inside the scoop net. Then from the scoop net, the fish are unloaded inside the insulated bins containing seawater and ice. 50% seawater, 50% ice. So the fish die from thermal shock. So this is a good way to keep a high quality of the flesh, high quality of the product. And another important thing is that fish must starve before harvesting. So we keep the fish fasting maybe one day or half day. This is different from temperature, but we don't want to harvest with full belly fish. So let's speak a bit about the last process I will show you in this presentation. That is the packaging, where the fish are packaged. So let's see that generally the packaging facilities are close close to the point where the fish are unloaded on land. So very few time. This is a very important aspect of aquaculture because we can ensure a very quality of the product because the fish die in the ice after 2 hours. Probably they are in the packaging facilities, so we can keep very easy the cold chain. Generally, our farm, the fish are in the supermarket after 24 hours or 48 hours from harvest. So very good. Packaging facilities, I mean, packaging can be do even manually, sorting the fish one by one from operator. But generally, of course, is done by automated machine. So there are a big machine that separate the fish for size. In maybe we can have a different exit. They can maybe make 8 different box, so we can set up the machine basing of our size, and this automatically is sorting the fish. Okay, the presentation is finished, but I want to, before to start with the question, I want to show some picture about this part of presentation. Okay, so let me open the folder. Let's start. To see. Sorry, guys, this folder we have very few pictures. You can see now, Mohammed, this is just a folder with some picture about stocking time. So the time where we put our fish in the cage. So this is a classical well boat.
Yeah, we can see the photo.
Okay, this is a video. This is a unloading from a well boat to a cage, big fish, probably 40 gram. This is unloading from the tank inside the workboat to the cage. Okay. This is a truck. A truck is unloading the tank of the truck in a tank inside a boat. Okay. Now from the boat, with the boat, we go to the cage, and this is the video of the unloading of the fish in between the boat, the tank of the boat to the final cage, the pre-growing cage. This is another unloading with a boat. These are small fish. You can see maybe 5 gram fish. We can handling 5 gram fish without no problem with a big pump. So you see the fish go in the pre-growing cage. This is 16 diameter cage. You see the anti-bird net lifted. I finished. Let's go to see some picture of very fast. No. Okay, these are picture about some net change, so operation, work operation in a farm. Okay, they are cleaning here. They are cleaning some rope. Okay, this is a divers that is going to make the inspection inside the cage. Checking for the holes. This is a net change operation. So you see net change operation, you can see on the right, you can see the new net down and the old net brown. Then in the middle, we used to remove the net, the old net from the middle with the crane. So crane is important. Wait, what's up? I jump some picture. You see the the growth of the algae on the net. So this is why we need to change the net. Or we need to clean the net, but do manually the cleaning of the net like with a brush is something that will not allow us to keep the net clean. So best way is to clean the net. Maybe I jumped a slide before, I don't remember, but once the dirty net are on land, we used to clean. Oh no, I say we used to have a special washing machine on land. This is an operation of checking a buoy, maybe cleaning the buoy, checking the plate under the buoy. So mountain base, this is an example of automatic net cleaning machine. This is a small one. This is a big one, another type of machine. You see, these are this disc that you see are pushing on the net and pulling water, high pressure water, are cleaning the net. This is the engine on the boat. So you see, this is pushing water, high pressure water for cleaning the net. Okay, this is an example of laundry, special laundry washing machine. Okay, this is not difficult machine to do. Can be done even homemade. Just we need a big volume to turn with water. This is a picture of the after the passage of the robot. Okay, so you can see the clean part of the net, the white one, and the dirty one. So then the robot is doing a good job. Of course, we in this case we have an operator on the boat that with the camera that is controlling, moving the robot. This is a way, normal way to do a transfer. So using this rope with all this ball, this small buoy, then we use to pull this rope and let's pass all the net without fish on one side, so that the fish has to be crowded on the remaining side of the net. So this is the way how we used to do to transfer fish from one cage to another cage. This was just the finish of the operation. Here was an operation of, you see the system is the same. This is a good system to obtain a pocket where the fish are crowded. In this case, the fish are very crowded, so we can put a pump and pump the fish from the cage to a boat. Here we were transferring fish from a growing site to a non-growing site. So from small cage to big cage. And this site were like 80 miles far. Okay, so we do the job with the boat. This is a transferring operation. You see that the two cages are connected each other with the net. So we have a door between the two net, but we need to force the fish to go on the net. This is some picture of harvest operation. Okay, we are almost done. We leave space to the question, guys. So you can see scoop net with maybe 300 grams of sea bream, 400 grams sea bream. The scoop net is tied to a crane. I mean, it's connected to the crane. So you see the fish were put inside bins with ice and water. This is another operation, always loading fish. Maybe these are 80-gram fish, maybe 50-gram fish. So no harvest. This we were loading the fish from the cage to the wellboat. So here you can see the fish go. This is a fish pump, guys. You see here the fish go on the bottom. That is good sign because a good fish go on the bottom. Try to avoid the bird production. So it's a signal that the fish is healthy and the instinct of survival is strong. When we unload the fish, we put the fish in one cage and it stay on surface, something wrong. This fish has some problem. So this is another example of harvest operation, small boat. You see, this is the net. This is the harvest net. It's a pulsei net that is made for the dimension of the cage. So if we have like 10 meter, probably we used to do 30 meter, 330 deep cage. But of course, if we have smaller cage, we will do smaller harvest net, but this is a design by basing of the net. So other beads, these are sea bass, always ice. Even in this case, we need a crane. So you see the fish are crowded in the harvest net. We can release the fish, some kind of fish we can release after the harvest. Some kind of fish we cannot release because we will die. So this is depends on the species. Anyway, okay, this is a picture just to show you the anti-bird structure belt. We call belt because the shape is like a belt. Belt, sorry. So I done with the picture, Mohammed. I get some video, maybe some feeding video, or maybe we can leave space to the question. What do you think, Mohammed?
Yeah, you can show the media because it doesn't seem like the chat is really that busy. So you can show the
Okay,
video and we do some
okay.
questions.
Once you prepare the question, you think about the question, I will keep showing some video. Let's show some video of feeding, guys. Hey, Mohammed.
Yeah, we can see.
Hmm. I have to show but one by one this video. the feeding boat. Okay, if you can automatic can, this boat can carry like 6 tons of feed. I show you. Let me. I'm gonna show you some picture and video about vaccination. That is a practice that is taking place in supplements in past aquaculture since 20 years now, in salmon industry more. I speak about infraperitoneal injection, so it's not immersion by bath. The vaccine is injected. So we need to do fully anesthesia. So you see anesthetized inside. I mean, not total anesthetized, but just to let them to be calm. Yeah, the people were preparing the fish from sides, making two different sides, small and big, and they were vaccinating the fish at the same time. This is another example of vaccination. These are like maybe 12 grams sea bass, so most small fish. You see the fish from the pre-growing cage were with in the harvest net, of course, were pumped into a first dose of anesthesia just to keep the fish calm. Then from here, one operator was catching the fish and put the fish in a deep anesthesia solution. To do vaccination, the fish has to be completely sleeping. I mean, no movement at all. So this is a vaccination table, a dry vaccination table. They were vaccinating the fish. And then you can see in 2 minutes, no more than 2 minutes, the fish go on the new cage, the receiving cage. They generally wake up once after they drop in the cage. Mohammed,
Valerio,
what do you think? We can maybe some question or not?
I think we'll do some questions. First of all, thank you, Valerio. That was a great presentation. You were really able to talk about both cage construction as well as operations in like one, condensed presentation. So that was really amazing. And interesting as well with all the media that you showed like
Nice.
real examples. Now we'll open up. Does anyone in the group chat, or if you'd like to unmute yourself and speak, does anyone have any questions? I see Alvin from St. Kitts. He says, what is the type of medication used for anesthesia?
But for anesthesia, we can use clove oil.
Mm, yeah.
Okay, that is a concentrated oil from the clove. Or maybe, I mean, in that case, we can use trigain. Is an allowed anesthetics. Or we can use phenoxyethanol. phenoxyethanol. So different, we have different chemicals for make anesthesia. But this is something very normal, very common, because and when we handling fish, we used to anesthetize them. So from especially from broodstock management for reproduction issues. So it's not for, let's see that the most cheap anesthesia used for do this kind of operation, so big volume of water, big volume of fish, is phenoxyethanol.
Mm. Another question Alvin had is he said, what size of workboat would be recommended for such a level of production? So I'm sure he was alluding to one cage or something that you had presented, but in general, do you have a perspective on the workboat size that they need for mariculture production? We can say the
Okay,
minimum size.
this of course depends from the farm.
Yeah.
Let's see that our farm, I mean, with 30-meter cage, 25-meter cage, 32-meter cage, we have generally catamaran boat, iron catamaran boat, that are generally no longer than 15, 16 meter. Generally, the wide of the catamaran is 6 meter, 7 meter, no more than that. But this is for big cage. For example, for what we did in Jamaica, doing two small cage, I mean 12 diameter cage, we can work with a 8-meter boat with a small crane. So like even no, a fishing boat of 8 meter, of course we need to leave space for work. So we can have a coverage, but we need to have a deck where we can have a space to do the operation. But I would say that 8 meter for 3 meter wide with a small crane is suitable for doing operation with small cage, so 16 meter, 12-meter diameter cage.
Okay.
Okay, okay.
Any other questions, comments, interventions? I see Alvin said replied thanks.
You're welcome. It's a pleasure.
Give him just a minute if there's any other questions or interventions.
I just have a comment. May I?
Yeah, go ahead.
Yeah,
Oh,
well,
this is
Valerio,
Daniel.
like
Ciao,
you
Daniel.
did, yeah, you did an incredible professional job. Whoa, impressed. So it's not a coincidence that we hired you for this project. It's because you're the man. No doubt
Thanks,
about it.
Daniel. Thanks a lot.
You showed him, man. The only frustration that I have is that you and I was with you and we did this, everything that you're saying and showing. We did it last year, the previous years in Italy, and you never showed any picture of those. And they're more recent, better quality videos, I guess. Next time we'll update. But it was absolutely outstanding. Very like classic presentation, stepwise from the get-go. And if I may again contribute for this project, because the questions are all, uh, they all proceed, but keep in mind that this project in Jamaica is a demonstration, it's a small scale, it's a pilot scale demonstration project. We're looking at the feasibility of red snapper and this type of cage. It is a protected bay, so the water circulation is not that great. We would estimate between half and 1 knot, and the depth at that particular point is 30 feet, right? It's 10 meter. So we're good for what we want. But obviously, as we grow and develop this further, we would need the, you know, places that are a little more like higher in energy.
Oh,
But the
uh,
comment is Valerio was incredibly professional, was really, really.
I'm agree. Thanks, Daniel. First, thanks. I couldn't make put some picture where even where we were together in Follonia, but in the end I didn't. Anyway,
No
no,
worries.
I'm agree with you. I mean, the scale. about the project we did in Jamaica is I like a lot this kind of project, but is a small scale project. So biomass maybe in 1 year we can harvest maybe 100 tons per year, putting more cage, of course, at this dimension. So without overloading the site, but of course we can do good. Speaking about environmental point, because we are doing no, polyculture with the oyster mussels growing, maybe with some sea cucumber in the bottom. So the impact of the environmental is very low. Speaking about the local market, of course, we can produce high quality protein in a suitable way. And of course, I was mentioning before, thanks for the question I received about the escaping, because allow to me to speak about what we were thinking from the beginning with Mohammed, about a project like this, because the site is very good, because we don't have waves. I mean, the reef is breaking the waves. We cannot put a lot of biomass because you save, no? We'll know a lot of water circulation, 10-meter deep. But in case of hurricane, we can have problem. We can have problem. So we were from the beginning commenting a strategy where we can shorten the cycle, maybe stocking pre-growing fish in 5-6 months. You can have 500 grams with this kind of species, so faster growth species. So we can even avoid to have the fish during 3-4 months having only the cage. So this is something that for me can be suitable, with in a repeatable in other place in the Caribbean.
Yep.
No, it's great. It's great. Any other questions? Any other interventions before we close off? Yeah, again, I'd like to emphasize the hands-on, real effort Valerio did when he was in Jamaica. He was working all day, making sure that everybody was getting, all his technical capacity, all his experience to really, develop mariculture there and then hopefully have a bigger impact for the Caribbean. So, as Daniel said, this is a pilot. And the hope is that the ramification of the foundational work we do now will lead into some real developments in the future.
Just to finish, Mohammed, even to finish to let's say my comments to Daniel, I think that we don't need to bring industrial aquaculture in the Caribbean. Like salmon, better than me. I've never been in Norway, no? Salmon is a great industry, they can move fish, 2-3 kilo fish in 3-2 kilometer. We need to do something different. We need to raise the level, to increase the level of the aquaculture. So doing something in the middle, in between what we do in Italy and what maybe you are doing now with tilapia on land. So moving on sea, and I think this can be a good window where we should move in the Caribbean for developing aquaculture in the floating cage. So not huge farm, but local market, small production can work for me, for my point.
Yeah, I think we all agree with that, and Mohammed too. I mean, we don't want to do it any industrial development there, but it's going to be based on several, relatively small scale operations that could, adding up to each other will make a huge dent in the production. Will move the needle.
And I'm seeing Alvin. Alvin's actually a aquaculture officer from St. Kitts. He's collaborating with us in the shrimp portion of our sub-regional mariculture project. And I see he's making a good comment that I'll just to make it more concise. He's just saying that there's a lot of potential within the Caribbean to develop mariculture, and even the livelihood creation that could result could be very impactful. So it's true, and that's why I think forums like these, where people can get that technical capacity, hopefully be inspired, are very important. Okay, sounds good. Well, thank you again, Valerio. Thank you everybody who joined the webinar today. Our next webinar is October 6th, I believe. Let me check. Yes, October 6th. And the title is From Hatch to Sea, Broodstock Larva Rearing and Fingerling Transport. So we have experts from the University of Miami as University of Florida, people who have real experience as far as seed production and broodstock handling and just really dealing with the real foundation of mariculture, which is being able to produce fingerlings that we can then grow out. So next week should be a really interesting presentation when it comes to seed production and contextualizing it to what we can do in the Caribbean. And yeah, I hope that between the cage and engineering and operation presentation we had today, and then the following presentations, we'll really have a good foundational understanding of finfish mariculture for the Caribbean. So again, October 6th is the next presentation. I'll send you guys a reminder based off of those who attended today and those who weren't able to attend. And we'll also circulate the recordings so that those who weren't able to attend today can be able to review and look back at some of the conversations that we had today as a reference point. So yeah, thanks everybody for joining. Thank you, Valerio. Thank you, Dan. Thank you everybody for the interventions, and I'll see you guys next week.
Thank you to everybody. Thank you, Mohammed. I was happy. Thank you, Dan. I was happy for this opportunity. So goodbye and keep in touch.